Hi, I'm Ciara Gunderson, and I'll be speaking to you on my senior capstone, the effects of dissolved oxygen on fish growth. Dissolved oxygen is a very important chemical within a water body. It tells and helps the fish figure out which type of water they are supposed to live in, as well as organisms within as well. In the winter, the dissolved oxygen within a water body is usually higher than in the summer. This is because colder waters in the winter and warmer waters in the summer. In the winter, the dissolved oxygen levels depend between 12 and 13 parts per million, and in the summer they're between 6 and 9 parts per million. And along with this, dissolved oxygen depends on a certain time of day, the vegetation coverage, the location, and other things as well. For example, as elevation increases, dissolved oxygen decreases. So if water body's in a higher area, then the dissolved oxygen will be lower, and species that like lower dissolved oxygens will be within those areas. For vegetation coverage, vegetation allows for more dissolved oxygen within the area because as the vegetation covers the water, it creates shade, which makes the water cooler. And along with this, it also uses photosynthesis. So as a byproduct, it creates oxygen, which allows for more oxygen. For the warm and cold water fish levels, warm water fish prefer lower dissolved oxygen levels, and they can live in oxygen levels as low as 1.0 parts per million, but they prefer between 5 and 6 parts per million. And for cold water fish, they can live in dissolved oxygen levels as low as 2.5 to 3.5 parts per million, but they prefer levels between 6 and 8 parts per million and above. For the economic importance, the economic value on cold water species such as trout and salmon is very high. As you know, we have the salmon river hatchery right here, but one specifically, the Northern Rocky Mountains, is a very important place for trout fishing, and a lot of people travel there. And the more people that travel there, the higher the revenues are for local and regional economies within those areas that they're passing by. So, as trout fishing is very popular in this area, it brings in about $750 million per year. And with global warming and warming the waters and everything around it, the dissolved oxygen decreases because the water is not able to be held as much. The oxygen within the water is not able to be held as much. So it would decrease the species that live there, and other species would replace them and that are less wanted towards fishers, and that would bring in a decrease of $103 to $192 million per year. So I'd say dissolved oxygen does have quite the economic importance on water. For my hypothesis, if I increase the amount of oxygen aerated through the water within the fish tanks, the growth of the fish within the tanks of high or medium oxygen aeration will not be greater than the growth of the fish within the tanks of low oxygen aeration. For my methods, I did a setup of 8 tanks up there with aerators, air stones, flower pots as houses, and filters within them. And that was my study site down at the bottom, underneath Eckel in the lab downstairs. But also, I did use Lakeland Park and Carpenter Pond. I collected my fish at Carpenter Pond in minnow traps, as you can see in the picture up here, for 4 weeks, and it did not go as planned. I got about 8 fish within those 4 weeks that I needed, which were bullhead and maybe 2 mad toms. And for BioBlitz on September 24th, the children that were working there, or that were there, and the people that were there helped bring in the fish with D-nets and seines. So that is how my project started, thankfully, a whole month later. And for my maintenance, I ended up changing the water 25% every 2 weeks. I rinsed the filters out weekly. I fed the fish 0.7 grams per week, or daily. And then I also did the dissolved oxygen weekly. I checked it with the same dissolved oxygen probe that Taylor used as well. And then I also took out my dead fish daily because there was a lot of those. And my timeline, I weighed my fish on September 29th or 30th, and then I did it on October 14th and October 30th as well, 28th as well. This is my final data collection for my control. I had 11 fish left over. For my low dissolved oxygen and medium dissolved oxygen, both of those tanks had 9 fish within them, and in my high dissolved oxygen tank there was 13 fish left. Remember this for the end. Very important. When I measured the fish, I used a little one of these, and then I put it on there, the scale, and then I put water in it and zeroed it out, and then added the fish to tell the weight of the fish. For my overall fish growth and mean dissolved oxygen levels, I did an ANOVA test, which I wanted to see if the levels had an effect on the fish growth overall. Unfortunately, there was no significance. As you can see, my p-value was 0.74. For the growth of the bullhead versus the sunfish and mad toms among the dissolved oxygen levels, these are 2 of the 4 t-tests that I did. These 2 are the 6.75 on your left and then the 8.38 on the right. And as you can see, the p-values are greater than 0.05, which indicates that they were not significant, as they're at 0.422 and 0.89. These are the next 2 t-tests that I did, and for these I had, these were significant. These were my control group, which was my 7.71, and my medium dissolved oxygen level group, which was 7.65. I did try to get them different, but it didn't work. But because they were the same, it just double proved it, I guess. Mine were 0.009 and 0.002 for my p-values, and that made it so they were significant, so there was an effect on the growth of the bullhead versus the sunfish and the mad toms among those 2 dissolved oxygen levels. This is one of the charts I did. This is a box and whisker, and this is just to visualize it for you, how much more they did have a percent change in mass than the sunfish and mad toms. In the orange is the bullhead, and in the sunfish and mad toms is the blue. This is just to show you and to put it in perspective more in case. This is another one. This is the 7.65 one, and I also thought this was interesting because in the 7.65, the bullhead had a very close range in what they gained percent-wise, so I thought that was interesting, especially since it was not that far off from the 7.71. This is the last test that I did. I did the growth of the bullhead alone among the dissolved oxygen levels, and this did not come up significant because my p-value was 0.13, which I was surprised because their percentages were higher than the others when it came to like my actual raw data sheet. For my discussion, as I was talking to you before, the numbers of the fish that survived, which were in my final data results, it was 11, 9, 9, and 13. I think that that was interesting because it did show that in the 11, 9, and 9 group, which were the first 3, it was, there were only 3 species that survived, and obviously the numbers were lower than the rest. But in the 8.38 parts per million group, which is my high dissolved oxygen level group, there were 5 species that survived, and it also had the most fish that survived as well. So I do feel like that the 8.38, the fish would prefer to survive in those areas, as more of a variety did, and a bigger number overall of them did as well. So I thought that was very interesting. For my results, all of my tests did come out, except for 2, came out not significant, but for the 2 that were significant, I did think it was interesting to see that the bullhead did grow better than the sunfish and mad toms, which is probably because maybe they were able to like hunt better in the 7.71 and the others died off too quickly, or I'm not sure, but I did think it was interesting. My hypothesis, it was obviously not proven, but I did find out other interesting things, as I just spoke about. If I were to further my studies, I would, 1, probably not use banded killifish or tessellated darters, because they died right away and it was not a good experience. Even before I started my project, I had them downstairs waiting to gather other fish, and they had like dots on them that were not supposed to be there, and I think that might have been why, but I just wouldn't use them. They were not very reliable. Another thing, I would want something so that I could, instead of having a valve for my oxygen to do the aeration, I would like a thermostat for an oxygen aerator. So like if it gets too cold, like you know how a thermostat, if it's like it gets too cold in a room, then it turns on and it gets warmer. I need that, but for oxygen. So if the oxygen gets too low, then it turns on. If it gets too high, then it turns off. So it's more consistent, because my values, it was very hard to keep them consistent. The last thing that I would want, if I were to further continue, I need more time, because time really crept up on me. But I feel like if I had more time, then my values would have been maybe possibly different. Thank you.